Grab your spotlight and go up to the clinical unit. In this case, we find the device turned on. It's a defibrillator. And we will turn on our spotlight SpO2 functional tester. Wait for it to go through its self-check. And we will then connect the oximeter sensor from the medical device. And we'll watch this bar down at the bottom. It's called the signal strength bar. You can see that it has a good signal, and you will begin to see the display on the screen of the defibrillator. Now, testing this functionally really quickly is just a 4-button push. We're going to go to our custom setup and go to custom 3, which is programmed for a patient with a high heart rate and a high O2 sat. See, it sets off the high limit alarms, which is exactly what we want it to do. We'll watch till the oximeter reading and the heart rate settle. And then we'll move to custom 2, which is a normal patient. We want to let the alarms continue to sound because the normal conditions will let them silence on their own, an important part of the functional test. Those to settle, and then we'll simply push one more time for our hypotensive patient with a low O2 saturation, low perfusion. And you'll see the alarms will sound again, this time on the low end. And again, we'll wait for the readings to settle.
We begin this test by plugging the AC power cord into the ESA. Plug the ESA into a wall source. Plug the AC power cord into the GI4000. Power on the ESA. Press the A button on the ESA to allow the device to power its test subject. Plug the GI4000 into the ESA. Power on the GI4000. We zero our test leads by pressing the OM button on the ESA. This will bring us to the protective earth resistance menu. Plug each end of the test lead into the volt ohm amp and ground null receptacle for the ESA. Press the F4 button to zero test leads. Earth resistance testing, also known as earth bond testing, tests the integrity of the low resistance connection between the earth conductor and any conductive parts of the device. Remove the ground end of the test lead from the ESA and connect an alligator clip. Place the alligator clip on the ground lug at the rear of the GI4000. The ESA will measure ground resistance. The earth leakage test measures the current flowing down the protective earth conductor with the mains inlet lead. To measure earth leakage, press the microamp button. Cycle through polarity, neutral, and earth settings by pressing the buttons on the side of the screen. Select normal polarity and closed neutral. The GI4000 will remain on in normal condition. To measure single fault condition, open the neutral line by pressing the neutral button. The GI4000 will turn off in single fault condition. Do not be alarmed. The GI4000 can be turned back on by pressing the A button on the ESA or by closing the neutral line and enclosure leakage displays the current that would flow if a person came in contact with the housing of the device. Place the alligator clip on the upper panel. Press the F2 button on the ESA to select enclosure. Test for normal polarity closed condition and single fault open neutral condition. Patient leakage testing is performed using the receptacles on the top of the ESA. To enter the patient leakage mode on the ESA, press the F4 button to select More from the leakage menu. Press the down arrow key to select the first applied parts group. Press F1 to select. We will use the right port of the argon receptacle for electrical connection to the GI4000. Plug a 4mm test lead into the far left receptacle on the ESA. Test for normal polarity, closed neutral condition, and single fault open earth condition. Unplug the test lead from the argon receptacle and attach the monopolar test adapter. Plug the test adapter into the monopolar receptacle on the GI4000. Test for normal polarity, closed condition, and single fault open earth condition. The bipolar test adapter divides the active and dispersive lines within the bipolar circuit. Plug each end of two separate 4mm test leads into the bipolar test adapter. Plug the bipolar test adapter into the bipolar receptacle on the GI4000. Go back to the leakage menu on the ESA by pressing F4 and then F4 again. This time, we will select the first two applied parts since we are testing with two separate leads. Plug both test leads into the first two receptacles on top of the ESA. Test for normal polarity, closed neutral condition, and single fault open earth condition. To measure pad safe system leakage, use the specialized test cord. Plug the neutral electrode test cord into the PSS receptacle on the GI4000. Plug the opposite end of the neutral test leads into the first two receptacles on top of the ESA. Test for normal polarity, closed neutral condition, and single fault open earth condition. At this point, the video has come to a conclusion. Please refer to the IEC 60601 guide to electrical safety testing for Class 1 Type CF medical devices and the GI4000 Operation and Maintenance Manual for full instructions on use of the device. To verify accurate test procedures, please refer to the GI4000 Functional Test Instruction for mode selection, settings, measurement specifications, and the most up-to-date acceptance criteria. After completing all test procedures, be sure to power down all devices and disconnect test leads. Thanks for watching, and see you in the next video.
This is a full-featured, compact, portable simulator used to measure the performance of patient monitors. The ProSim 8 simulates ECG functions, respiration, invasive and non-invasive blood pressure, temperature, cardiac output, fetal simulation, and SpO2. The ProSim 8 is intended to be used to test and verify the basic operation of patient monitoring devices or systems used to monitor various physiological parameters of a patient. The ProSim 8 can also be used to calibrate in some cases and can also be used for training purposes. If we look at the front panel of the device, we first see the 10 ECG posts. They are easy to disconnect and connect. We also see two IVP channels, temperature, cardiac output, SpO2, which is currently connected to our spot, NIBP, an LCD screen, as well as various functional and navigational buttons. In the rear of the device, there is a USB port for remote access, as well as a high-level ECG output. As we look on the bottom of the device here, we see various patient disease states and chronic conditions. These are exactly as they would appear in a patient. All physiological parameters are correlated so that they reflect of patient to the patient monitor. You can also go through the functional buttons to adjust these. So right now, we'll be in normal, we'll go to ECG, and we can adjust the heart rate to exactly what the patient monitor manufacturer states in their service manual. We can also do the same for NIBP by adjusting the blood pressure in 1 millimeter of mercury increments. We can also go through in SpO2, where we can also make the same adjustments, but we can also choose the type of pulse oximeter so that we're using the right bar curve. In IBP, we can choose the chamber, pressure, and artifact. Moving to special functions, we can see respiration, cardiac output, temperature, and fetal simulation. There's also the option to use auto sequences. Now, there's a list here, but you can also create your own. If we go into the first one, monitor testing, we can see that there are 3 steps. If we were to start this, the 3 steps would be performed and the results would be displayed to us to manually save as pass or fail. We could also record them right then or there. So if we exit out of here, you can also see that we have onboard memory. When you save those results, they will be saved on the onboard memory for you to observe at your desk after you've come back from a day of testing. You can see which tests passed and which tests failed. And if you wanted to take this one step further, Fluke offers their Answer software platform, which allows for you to write test procedures, save test results, and automate the pass-fail procedure. If you have any questions,
on the IDA-1S, we have a real simple setup. All we need to do is hit flow on the test. We would put in any patient name if we had any. We're just going to skip through. We're going to connect the pump as it requests. We already have. I just showed you that. And the most important thing here is notice the red bar. That tells you the device is not primed. This is where the syringe comes in. So as I press on the syringe, you'll notice that the blue bar, or the red bar, shows up as a blue bar. There it goes. And once it is completely blue, you're actually ready to go. Don't forget to change your switch to close the syringe and open your infusion device. So at this point, all we need to do now, I'm going to start my infusion device and I'm going to start the test at the same time. Start and start. You should see some numbers coming up shortly. That lets us know the device is currently functioning properly. And another thing we can do, we can actually test water dripping into our beaker. So this should take about 10 minutes. We'll come back here in just a few minutes and see where we're at.
Exactly, because exactly, that's troubleshooting, that all seems to be in place, and things are, interfering with that. You got a calibration issue, and I will show you how to calibrate this machine.